Okay, so in the previous video, we had looked at the Dalton's atomic model, which was a billiard ball model, and we looked at the chocolate chip cookie model, and we explained what happened in those models to allow them to be developed, and then why they were rejected. So the chocolate chip cookie model by Thomson suggested that electrons were spread throughout the entire sphere of the atom, and that was rejected because they discovered a nucleus. So that discovery was made by Ernst Rutherford, and Rutherford came up with what is sometimes called the beehive model. And essentially his idea is that the electrons are traveling around a nucleus in space. He thought of them like bees traveling around the beehive. And so this was developed because experiments showed a dense middle of the atom, and that's the nucleus is what he's describing. So the discovery of the nucleus got rid of the chocolate chip model and allowed for this beehive model to be developed. Now, the discovery had shown that there was a positive, dense nucleus and that electrons circle around the nucleus, but most of the atom is empty space. And the experiment that brought Rutherford to this idea was he shot alpha particles at a gold foil. So gold foil was a thin layer of gold, and alpha particles are these positively charged particles, and they shot them at very high speeds, and the particles hit the gold foil. So I like to think about this like it's a little bit like Red Rover, that game, Red Rover, we call so-and-so over, and they'd run and try to break through the lineup of kids holding hands. So like kind of a little elementary school game. And so what Rutherford figured was either those particles were going to go straight through the foil because they had so much force that they could just go right through it, or he thought instead maybe they would bounce back, right? Because if they bounce back, they are hitting the wall, and basically the wall reflects them back. The gold is dense enough, and it is enough of a barrier that the particles bounce back. And if you think that the atom is a solid sphere of positives and negatives all mixed together, either the particles are going to go straight through because they've got enough force, or they're going to bounce back because they are hitting a dense solid thing. But what ends up happening here is that the alpha particles, as they're traveling through, most of the alpha particles continue straight through. Most of the alpha particles go straight through the foil, but some of the particles bounce back. So this told Rutherford that the particles there are some particles that are hitting something dense enough to send them back. They hit the wall and then they get bounced back. But most of the particles can travel through the wall. So this suggested that the atom actually has quite a bit of empty space, and there's a dense part of it that will bounce back. The other thing, though, that they found was that some of the particles got deflected. And since the alpha particles are positive, they deduced that the nucleus was dense and that the nucleus was positive. So the dense nucleus was also positively charged. And so this experiment allowed them to detect this positive nucleus, and then they said the electrons are probably mostly in empty space traveling around the nucleus. This model was great. It helped to explain the presence of protons and neutrons in the nucleus. It allowed to explain why atoms have this variety of size and it was good, but then there was a further discovery that electrons exist in orbitals. So the electrons don't just randomly travel around like bees buzzing around a hive. Instead, the electrons are organized into orbits. And this is the Bohr model, and we end up studying this a little bit more and do Bohr diagrams of the atom. So the Bohr model says that electrons give, or the evidence that supports this is electrons give off some light as they lose energy, and this gives an emission spectra. So you may have studied emission, absorption, and continuous spectrum in Science 9. But essentially, atoms, when they're given enough energy, give off light. And they give off specific patterns of light. And it's related to whether the electrons are in one orbital or the other orbital. So electrons in different orbitals give off different wavelengths of light. So the Bohr model says that electrons circle the nucleus in specific orbits. Those are called energy levels. Sometimes they're called shells. Electrons, it turns out, also act as waves and particles, and this dual nature of electrons made it so that the Bohr model needed to be improved, and so we have still got further models beyond the Bohr model, but the Bohr model is the one that we will stop at in high school chemistry, and you will be learning more about Bohr models of the atom a little bit later.